on my laptop on my lap, so you're going to have to forgive me for stuff. But let's see if we can figure out what did we do last week. I think I've opened it. Let me share my screen. There you go. Close this crap. Okay. Does this look right? Yes, I think so. Let me put this on the side. Wherever. A little smaller. This can be bigger. Okay. So I think last week we just got to the part where we were like, I think just the basics of ELM. So let's look at our cool program. Yeah, okay. So we had a program that had like really two primary functions. It has like an update function. It has a view function. The view function is the thing that knows how to render effectively a model. I'm just going to put your faces up here. Hey, you have to go screens on, Bhavesh. Sorry, man. You know this rule. I mean, videos on. Otherwise, it's like not a tech session. Rampton, Jonathan, Jono, same story. So, and then you get to see yourself. Isn't that fun? So we have a view function, which takes a model and generates some HTML. We had a cool diagram earlier, but that makes sense. And then we've got an update function, which, yes, given that same model, the old model, and some kind of update to it, some sort of message, will produce a new model. Does that make sense? So with literally those two things, I mean, it sounds pretty basic, but like with that, you can build an entire web application. Do you agree? Like everything can be done in a web app with like an update function and a view function. Does that make sense? Are you guys comfortable with that kind of idea? I mean, like this is the basis of like Redux. Redux is this. This is the basis of React. React is this. It's also, I mean, just maybe in a more convoluted way, but effectively, React is this as well. It's a whole lot of templates and some kind of like stateful model and your ability to change that state over time. But you can really reduce it in ELM down to these like two very distinct functions. Does that kind of make sense to everyone? Everyone happy with that idea? Any questions on that stuff?
No question, but view X, also the same story. I know there's a few guys using Vue, so it's.
Oh, Vue, yes.
Yeah.
Vue, yeah. VUE. Yeah, exactly. Yeah, Vue is basically the same.
They have a Vue X thing. Vue X is
right,
like
Vue
the
X,
Redux.
yes, which is a reduxed version of Vue. Yes, absolutely. Yeah, absolutely. So ELM figured this out a long time ago, and then a lot of web frameworks have gone, oh, look, it could actually be this simple. And Redux came along, and then a lot of frameworks like incorporated Redux into their model. So we see, so ELM really, I think, moved the industry forward with this kind of just like so simple idea. Okay, so we never dealt with this line up here. So we dealt with the model and the messages, and we can get into, did I? Oh, yeah. And messages. So, and we'll get into like maybe more detail around this thing, but we never dealt with this main piece up here. So this is really like the main program. So I don't know if we have to call it main. I think you have to have a function called main. I assume that is called here somewhere. elm.main.init. Okay, so I assume if we called this something else, main2, we'd get some kind of error here. Say, when producing a JS, I require that the given file has a main value. That init is definitely defined in the. Okay, so it is important that I suppose as the entry point to your application. So whatever it is that you're launching here. So technically we could, I mean, this is from the template. I just copied and pasted this, but this technically should be called like main, you know, like my app's main, and this would be strangely main.main.init. I'm not sure if that's amazingly good, but and so that's maybe why they called it ELM. But technically, when we're importing that thing there, we're saying this is the entry point to our ELM application, and this elm.main.init, which is imported up there, somehow under the covers is calling main, right, to set itself up, and that obviously needs to be there. But you can get a bunch of different like of these like applications, I suppose. I think you would call them, or runtimes or something. In Elm, we're just using one called browser.sandbox, but you can have a bunch of different ones, and they have different sort of levels of power or levels of advancedness to them. But let's just quickly add the function signature to main here. Sorry, I can even get it to generate it. Yeah, let's add that annotation. Okay, cool. So we can see that main is of type these four things. And remember earlier when we were talking about this of story, HTML of message, it's like we've got an HTML that is specialized on my messages. When you read this, you should see that program is specialized on these three things. So it's like, and I think earlier in the last session, we said generics or whatever. Like we said, program takes three generic parameters. And these are them. There's this one, which you can ignore, which is called unit. We'll come back to what is unit later on. But if I hover over program, we can see that the type program has got three kind of arguments to it. And these are not, these are type arguments, type parameters. So they're not like function parameters. They're not actual values. They are types. So and so they're much more like generic arguments. You know, in another language, you would have program, and then it's like of type, you know, type T or something. I suppose you could have T, U, and V, you know, as type arguments. You know, this function. Does that make sense? So that's really what this is doing here. Is it's taking this type program, which is obviously written in Elm. It's an Elm thing. And we're specifying, we're passing in three type arguments to it. The first one being unit. Effectively, this means like nothing. Unit, it means nothing. Yeah, it means nothing. Let's just pretend it means nothing. That's what unit means. It actually means something, but there's only one of these somethings, and so therefore it's nothing, if that makes sense. So the first argument is unit, and so we can see that it's like, okay, so program takes three arguments, one called flags, another called model, and another one called message. These, because these are lowercase, we know that they are type arguments. If they were uppercase, we would know that they were concrete types. Does that make sense? So remember, all types in Elm have to start with an uppercase. And because these are lowercase, but they're in the position where you might expect a type, then we know that it's like a type variable or a type argument. Yeah. So you can see flags is empty. The model type is of model. So we're saying the model type for program is model. And remember, model is our type. And we're saying the message type for program is my messages, which is our type. So we're making it concrete here. We're specifying those parameters. You happy with that, Kieran? I see you.
Yeah, so what would happen if one of those type parameters was also a like HTML of model?
Yes.
How would that look?
Yes, it would be bracketed.
Okay, cool.
So it would be, you could have a my message, and we can, like, actually we can do that. Why don't we just do it? So we could have a type like, we could create our own type, which has an argument. So we could say like, maybe, I'll just come up with something crazy, but let's go type, what would be useful, like a type point or something, right? And we could say type point has got two, so like a point, I'm thinking of like a Cartesian point, right? And it's got an X and a Y, right? And you might say, well, it's not always, so I could say, okay, well, type point is like a record type thing. And I could say the first thing is an int and the second thing is an int, right? Something like that. How do I make a record in what am I doing wrong here? Elm experts jump in. How do I like make, oh, maybe this needs to be an alias. Yeah, okay. Type alias point. Okay, yeah. Oh, yeah. So what I would if I was making an actual constructor, sorry, I would have to specify a constructor, yeah. So, I mean, this, without understanding this too much, you can see that I can create a new type called point, and I can say it's got two fields like X and Y, and they're both of type int, right? But I might want to say, oh, you know what, point doesn't have to be ints. It could be like, it could have some other, it could be like floats as well, right? And so maybe I'd want to make this int thing more generic. You know, I don't want it to always be ints. I wanted to make them of type A. You know what I mean? So then I could create a type point of like lowercase a, and I could say, oh yeah, so a point of any type always has an X of that type and a Y of that type. You know what I mean? If it's a two-dimensional point, right? Does that make sense? So, and so that's how I specified. It's like as simple as that. And so if I wanted to say that my model for this program was, my model was of this point type, I could say it could be like a point of int, and I could specify it up there. You know what I mean? So like my model for this program is always a point of type int. I think I could also go though that could also be point of type A there, and I could continue saying I'm not specifying the type. Like the model could be of any type, effectively. Do you know what I mean? So does that answer your question a little bit? So brackets is the answer. So like the parser, when the compiler parses this and it sees the word program, it goes, oh yes, the program type requires 3 arguments. And then literally the compiler just eats the next 3 arguments, 1, 2, 3. It goes 1, 2, 3 based on white space. It doesn't like reduce. It goes, needs 3 arguments, 1, 2, 3. It eats them. And so if this was more than 1 argument, like if you went model space A like that, the compiler would say, well, it's a program constructor and this, a model and an A. You know, it wouldn't supply the A to model. So in order to do that, you need to make sure that there's 3 arguments. Do you know what I mean? So you bracket like that. But, and this can be a bit funky sometimes, and it's only, you just have to be like the deal breaker when there's like ambiguity around bracketing. You know what I mean? Because there's not a lot of bracketing in this language. You have to help the compiler along sometimes still, because things can be confusing. If that makes sense, because white space is quite meaningful here. White space is literally separation of arguments. Do you know what I mean? So it's like, what would you say? Is it left associative? Is that it? It's something to do with around associativity, that it binds closer to the left. Yeah, so it's like left greedy or something. I can't remember exactly how you would say it in language words, but that's how it works. Yeah. Okay. Any other questions? Are we generally happy with this? This unit thing's a bit funny. Should I explain unit? What this thing means?
Just wanted to ask with the like generics that you're mentioning, well, like the generic you can pass like an A and make it of type A. Is there any way to restrict the type? So to say it's like generic, like in C# you'd say it's a generic type, but that type has to inherit from like IEnumerable. So I only want to be generic lists.
Yes. In ELM, there may or may not be.
Okay.
But in proper functional languages, yes, absolutely. So I don't know in ELM. Matt, do you know? Where can I go, like say I had that, it was like with that cool point example, right? So if I go type point of A equals a constructor with X of type A and Y of type A. Can I say that A is constrained by something? Like it must only be something which is...
so it must only be numbers, maybe not strings. So you use it as a coordinate system. Yeah.
Yes, exactly. So I don't know in ELM if I can do that, but because in real functional languages, you would call that type class constraints or something. Type class constraints in ELM? I don't know. Type classes, and I know for a fact that ELM doesn't have type classes. And look, there are people who are wondering about type classes and reading types. So how would I do this? Don't know. Let's try and figure it out. Type aliases. I think we may not be able to. Just
From what I can
Yeah.
see, there are some like built-in type classes like comparable and stuff, but
okay.
you can't make your own. So there's a couple like number and that kind of thing.
Where did you find those? Have you got a link to it?
Stack Overflow.
Okay.
I'll post it.
So like built-in types. Yeah, because I think we saw earlier that there was something called like number, and it was like could be that number because it's a lowercase thing. It's really a type argument, but it could be that Elm then goes, oh yeah, but you can't have a. Let's just try it. So we'll say, well, A is a point where X is hello and Y is goodbye. So this is now making it a string, right? Oh, sorry, I think I have to go equals here. Do I have to? Don't know. Type mismatch. The record of type string, but point needs the first argument to be number. Yeah, okay, so that's interesting. But if I just made this n, then it's all good. Yeah. So there's some sort of known variable names that if you use that variable name, the compiler will constrain you. Did you pop a link?
Yeah, it doesn't look like there's like a good authoritative list of them. So, but there's like comparable.
Yeah, absolutely. Yeah, okay, so comparable, appendable, number. Yeah, those all make sense. And so in a real language, because keep in mind, like Elm, although it's a great language and it's awesome, you'll learn a lot. It's very constrained, and because Evan says like he doesn't want people to have to figure out types and type classes and be like into category theory and stuff before they can pick up and be useful in Elm, because that is one of the big criticisms of Haskell and therefore PureScript, etc. That really there is some complexity in those type classes, and there's a lot of power in it, but like it's not easy to just pick up and run with. So just to give an example of what this may look like in Haskell, you would say like type, and the syntax is not going to be perfect, but what you can say is something like this. You would say, we'll go back to just using type variable A, like that. And you would kind of go at the beginning, you would say like, yeah, but like A has an odd type class associated with them. And often they use like a funny notation. I don't want to confuse you with the notation, but there would be a way of specifying somehow for this type that it abides by the ordinal type class, but it could also abide by the equal type class, or it could also be part of the num type class. Do you know what I mean? So there would be a way of saying that you can only construct a point of A if the type A has an implementation of odd, EQ, and num attached to it. Does that make sense? That's how you would do it in a grown-up language. And the syntax is not exactly right. Yeah, it usually uses like a funny double fat arrow type of notation. But that's how you do it. And this is very similar to, Miguel, your example where you said in C# generics that it's like that num is of type I enumerable or something. It's exactly the same. So I enumerable means that that it is something that can be like iterated over, right? And I enumerable is something which implements the what is it, like the .next function or something, or has next and .next or something like that, right? So, and in Haskell, I think, what would that type be called? It might be called like a semi-group, or it could be called what is it called? Something. Oh, it would be like a functor. It would be a functor. Yeah, it would be a functor. Would make sense. It's something that you can iterate over. You can apply a function to elements within this thing. That's really a functor, which is similar to like IEnumerable. So IEnumerable, I suppose, is a kind of a functor, if that makes sense. All right. Happy with that? But yes, it looks like in ELM, if you want it to be numbers, you can use number comparable. That probably means that you can do equals on it. And what was the other thing? We had
appendable.
Comparable. Oh, and appendable. Appendable means I could probably go like plus on it. I can make I can add to it. So like because number tells us a bunch of stuff, right? Number tells us potentially that I can add these things, subtract them, multiply, and divide them, right? That's what I can do with numbers generally. And maybe there's like some notion of a zero element, right? Some kind of zero attached to this thing. Comparable means I could probably check them for equality, but I can also probably check if they're greater than or less than equal to each other as well. You know what I mean? So I know that they're the same, but I also know maybe, I mean, I wouldn't normally call that comparable. I'd call that like orderable, right? Something that has an order to it would have that, and comparable would just have equality, because they're not always the same, right? So like, for example, strings can be checked for equality, but it's a bit daft to say that one string is greater than another string. Like, that's a bit stupid. But then other things where I can like and then another interesting one is like floating point numbers may not have an equality actually, because I can't check them to be equal because of precision problems, but I can see that they're greater than or less than each other. Do you know what I mean? Does that make sense? So like orderable and comparable are not always, like, I would say not necessarily the same thing. There's like different layers of interest, like, yeah, it's like a matrix of things. So some things have, and then appendables are things like a string, for example, is appendable. A list of things, a list of any things is kind of is appendable as well. If that makes sense. Yeah. Okay. We comfortable with that? Any other questions on that stuff?
I had one.
Yeah.
So you referred to ELM in two different ways, that it's not a proper functional language. You said it was also not grown up.
Yeah, it is a proper functional language. Absolutely. It's a pure functional language, definitely. But it's a bit of a toy language. So like you do get to the point where things like this, you go, I wish it was a little bit better. I wish I could implement type classes. I wish, like, a little bit more powerful. Yeah.
All right, cool. Yeah, no, I was just wondering why you thought that. Is it just because of the specific constraint on the generics thing that we just discussed?
Yeah, this is one example. Yeah.
And other things like it.
Yeah. There are some other examples. So one that jumps to mind is like the pattern matching in ELM is very good, and but there's kind of only one way to do pattern matching in ELM, which is with the case. Is it case element of something like that? I can't do case. I can't do pattern matching in like arguments. So Bhavesh, you would know this from pure script. You can go like, say f takes a like a maybe int or something, right? And it gives us back something, a string or something, right? Creating a function like that I can give it a maybe, right? And not everyone may know about what is a maybe, but Bhavesh should. And I can implement this function by going, yes, f of like whatever this maybe int, I'll call it mi maybe int, and I could say case mi of just some I, and then I go good, or if I get nothing, then I go bad, or something like that.
Yeah.
Right. So I could implement the function like this, but in pure script, we know we can do it even nicer, because I can go f of just I equals good.
Destructuring.
Yeah.
Call it. Yeah.
Exactly.
Okay.
Yeah. So I can destructure it straight in the arguments, because I can have multiple definitions of f here. Do you know what I mean?
So ELM can't do it.
And ELM, I don't think it can. Remind me, Matt, but I think no. Matt keeps just being silent. I think I'm just using him as like a speak to myself.
I don't
flow
think
of consciousness. I don't think I can. Yeah. So I think in ELM you're forced to use the case thingy. I think I discovered that but like when I came back to ELM, I was like, oh, it's quite crap. Pattern matching. So we haven't really dealt with it, but like this is the way you pattern match, is always with the case something of, and then you put your case there. That's cool, and that's it.
All right, cool.
There's no other, and that's good enough. That is good enough.
It
but
will
it does,
work, yes. It just forces you in.
Yeah, exactly.
Right.
So it's like, oh, okay, it's not as like, I don't know. You know, I've now got to write a 5-line function as opposed to 2 lines with a natural pattern match in it. You know what I mean? So there's things like that. So with Elm, you're definitely forced to be pure functional, though. There's no escaping that. There's no like ability to create side effect, nothing. It's like properly constrained from a pure functional perspective, which is amazing, and it's very cool. And once you get comfortable, as soon as you get comfortable with Elm, you'll go, "Ooh, I need something better." You know what I mean? I wish I could just do something a little bit more. But that's not a bad place to be, and it's a great gateway. It's a gateway drug language. Any other questions? Comments? No? Okay, so what do we propose that we do next? Oh, yes, we were going to do a Chuck Norris thing. Does someone want to help with this? Did anyone make any progress with Chuck Norris? I know Matt and Chart did.
Yeah.
So what were your thoughts, Chart?
Happy to help.
So we're gonna find the Chuck
what's
Norris
the best way to do it.
Is that the best thing to do? I think it is. Browser.sandbox. Oh, so maybe we should have talked about this quickly. Yes. So yeah, I think this is important because I don't think we can use the sandbox for that, right? We need.
Don't think
can
so,
we?
no, because the
can't.
element needs subscriptions, but I'm unclear because we don't use subscriptions. But if I look at their example, Sandbox can't almost talk out. You know, that's sort of how in layman's I understand it. So
Yes.
I think you
Correct.
do need to use something that allows you to have sort of side effects, I guess.
Yes. Quite right. So let's just try and explain that one. So when we look here, this is what browser.sandbox really is. It is like, it's called a sandbox because there's literally nothing other than the events you can generate yourself here that your program can handle, which would then come back into the HTML. So you can only generate events inside this thing. There can be no events coming in from the outside world. And also, you cannot generate events which go to the outside world, if that makes sense. Do you know what I mean? So that is what browser.sandbox really is. So somewhere here, though, I do think, doesn't it talk about the different types of these program
things? I think it's under HTTP or under subscriptions. So go a bit up. Commands and subscriptions, I think there's Sandbox.
Good. Okay, good. So yes, all we can see. Oh yeah. So I said sandbox, but really what it means is like the only events you can handle are ones that come from the DOM. Do you know what I mean? So the DOM is like you know what the DOM is, right? The DOM is like the browser rendered application. So I can click buttons and I can handle those events, but I can't have data coming in from anywhere other than the DOM, like no network or something like that. So I'm hoping, yes, great. Okay, nice new picture. So now so that was what Sandbox is all about, browser.sandbox. You can think of setting up a system like this. We get to stay in the world of Elm, writing functions, transforming data that hooks up to the runtime, can figure out how to render HTML. Did anything change? What is the minimum DOM change? Yes, message feeds in. Using a common blah, 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 blah. Okay, good. And then in the first, we're going to use element to create programs. This will introduce the idea of commands and subscriptions, which allow us to interact with the outside world. So now the picture kind of changes very vaguely, but it effectively just adds a few other things. So it's like now with element, we have the DOM, of course, but we also have HTTP. So that means we can talk, the browser can make requests to the outside world. It can also get stuff like, oh, what is the current time? That's quite cool. So in browser.sandbox, we had no ability to get the time. Because if you think about it, the time is like an unstable thing. It's a non-pure idea. The time is not pure. If I could write a function that gave me the time, that would be an impure function, because if I called it twice, I wouldn't get the same result. So that would be impure, right? So technically, that's something that cannot be inside your application if it's a pure application. You couldn't have getting the time. Same is true of randomness, right? So if I say get int and get int again, I'm going to get two different things back. That's an impure function. It can't be handled in a pure functional language. Of course it can, but it can't in this. Like, I can't write a function that gets me the time. I can't write a function called get time, which returns me in int, which is like the number of seconds. It is impossible. There's no way to do it. So there must be some mechanism, though, to get it. So let's just read this. In addition to producing HTML values, our programs will also send command and sub values to the runtime system. Okay, cool. So here's our program. Is that correct? Yes, here's our program. And when it generates HTML, it generates it to the runtime system, which then renders the DOM. The runtime system, though, generates messages back into our program with things that are changing in the world, which could be the DOM, HTML, HTTP, the network, time, and randomness can come back into our program where we can handle them in a pure way. And then, so I think in the previous example, all we would have seen here is ELM generating HTML to the runtime system. Now we are seeing that our program can generate HTML, but it can also attach commands and subscriptions to that runtime system. Does that make sense? This almost tells you that it's like we're going to be sort of preloading the runtime system with things that we're interested in. And when the runtime system sees changes in those things, it will pass them back to us in terms of messages. Does that make sense? The only way to get stuff into our program is through messages still. So everything has to be a message in from the runtime. Doesn't matter where it comes from, it has to be a message into our program. Yeah, sort of happy with that, but we'll get there. In addition to producing HTML, we'll also send command and sub, yes, and blah, blah. They can also subscribe to the current time. Okay, so subscriptions, I don't think we'll deal with. I don't think I actually don't encounter them often. I think commands and subscriptions make more sense when you start seeing examples. Okay, great. There's some good examples. Anyway, okay. So I think the point is, let's just switch to element so that we can do more. This effectively means that our main now is not going to be browser.sandbox, but now browser.element. And if we do this, we get a whole bunch of errors telling us we're probably not passing enough stuff here. This argument is a record of type. So I'm passing these three things, init, update, and view, but it's saying, oh, but element needs the first argument to be init. Init taking flags to a model command message. Subscriptions is totally missing. Update takes a message, a model, and returns a model with a command message. And view takes a model. Okay, so view remains the same. That seems to be the same. But update looks different. Init looks different. Yes. And subscriptions we are missing completely. So let's just try and fix.
What does those hashes mean? Like there's two hashes around subscriptions.
Yeah.
Does that mean it's not there, or what does it mean?
I think what ELM is trying to do is just trying to highlight to you what it's talking about.
Okay. Trying to highlight,
you know what I mean?
where the issues is.
I don't know exactly what it is, but often it's the pointer. It's like trying to tell you here's the problem. You know what I mean?
Okay.
If this was
pretty cool.
Yeah. So it uses, so it's almost saying like that's gone. This thing is like missing. It doesn't have this thing, flags. Only int and float values work as numbers. Okay, I don't know what it's talking about there, but let's try and fix this. So we can see that init, let's actually just copy that out because it definitely, oh look, actually the hash does start and end like that.
It's like highlighting the area that's wrong.
It's almost highlighting it, yeah. So I suppose if this was colorable, you would make that red. You know what I mean? So if it was like markup or markdown or whatever. So let's just fix our init. So we know earlier with browser.sandbox, init just required, let's actually go back there, sandbox, because I don't think we even really ever looked at init. But init was, it just needed something, it just needed one of our models. So, and because our model down here was an int, we just gave it 0. So any value for init would have been fine. Init was just a model. Does that make sense? So if I hover over sandbox, it might be more explicit. Yeah, init is just a model. View takes your model. returns an HTML message. Your update takes that message. And when you see the word model and model here and here again and there again, and because it's lowercase, we know it's a type parameter, but they're always the same. So whatever I pass to init must be the same type as this one, must be the same type, same type, same type. Do you know what I mean? So wherever it's lowercase model and you see it repeated, that means that yes, so whatever I set model to, so if init takes an int and I'm making that an int, then view must also take an int, and update must take an int, and that must be an int, and this must be an int. You know what I mean? So as soon as you make it concrete, it must be that variable becomes like set to whatever type is there. So you can see that it's always the same type. So whatever model is here, it must be the same for init, so we know it's an int. That makes sense. Okay, let's go back to element. So init now we know takes a flag. Yeah, let me just copy this. So I'm using my trackpad, which is super irritating. Okay, there we go. So we know that init, just write it like that. Init takes a flags and must return a model and a command of my messages. So we can actually do that. Like do we have command yet? No, we don't have command yet. Do we have to create a new type for command? Yeah, I suppose we could. So let's just try it. So if we write a new function, so this is init is taking a function. Does that make sense? So let's just write a function right here. We'll take an F. We can call it flags if we want. And then we want to return a model. So we know our model is an int. We're going to go int 0, and then it wants a command of my messages. So I think I can just go command.none here as a start. We'll come back to this command thing, even when I refresh my own memory on it. Does this make sense? I think probably our error has moved on now, I'm hoping. Yeah. Okay, so we've kind of solved that one. The other way I could have done this, and you tell me which is better, is I could have made a new function called init and gone, okay, so init takes something like a flags, and it returns something which is a model, and then a command of my messages, right? And I could say init with f equals 0, command.none. Are you happier with that form of init? I just wrote it in line like that. But let's do it like that, right? You happy with that? Init equals init. What's the problem here?
It's the extra bracket.
Yeah.
Oh, sorry. Yeah, quite right. Okay, good. We're happy with that. You're generally happy with that. So now we've solved, I think, that one. So there's no more highlighting of that. No more cool hashes around it. Now it's saying, oh, but you're now missing the subscriptions thing. So let's implement it. So we know subscriptions need subscriptions. So it needs to take something which takes a model and returns a sub of message. So let's just write it out like this. Subscriptions is something which takes a model and returns a sub of message. So let's go subscriptions, taking the M equals, and it's like sub.none. We're just going to return nothing. So there's obviously a magical module called command. I wonder what this thing is actually. What is he? I don't know. Yeah, it's a type, I suppose, but it has on it a .none, which is like I'm just going to return nothing, no command, and sub has got something which is none, so it's like return no sub, because this function subscriptions has to return a sub of message, and we're just going to say return none. But this should get rid of hopefully the next one. Here we go, subscriptions equals subscriptions. Then let's see what our issue is now. So now it's saying, okay, yeah, but your update function is wrong. The update function needs to take, let's just grab what it thinks it should take, because here's our update function. Here's what it currently looks like. And it wants it to look like this. It wants update to be a my messages to a model, and then to a, pick up these funky things. Oh, it's like, oh, okay, so update doesn't return just the model. It must return a model, a tuple of the new model, but then any commands that you want to attach to it. So, oh, okay, cool. So let's fix that. We want that to be command of my messages. And now it's like, oh, okay, shit. So now that compiler error is gone. But now it's like, okay, but you're not doing that. You're just returning the model. So it's like, oh, okay. So wherever I return something, I'm supposed to return command of none.
And it's pretty cool. You changed one thing. You changed sandbox to element. But now you get to implement a whole program with just following the compiler.
Following the compiler, exactly. So it's like, because it's type safe, it's good. So hopefully, I don't know if I'm actually compiling stuff. I think I am. And we just do this. Who knows if it's actually, I mean, sometimes these things I always, sometimes don't trust them and restart them just to go like, did you actually compile? But it's like, okay, good, seems to work, still work. And now we're running in browser.element mode. So now we've got this like upgraded update function, and this extra cool thing called subscriptions. So that sounds good. So like, why would we want that? I wonder if there's a way.
Tom, before you move on, can you change the value of init and recompile? I just want to see if it, like that 0, can we change it to like something? I just want to see.
It has hot swapping, but it just doesn't work always.
Okay, cool.
I don't know why. Mine also just sometimes works, sometimes doesn't.
Okay, cool. Thanks. Sorry.
But it does seem to bring in the new value when I hit refresh. So it's like the compiler seems to recompile, but I don't know if the browser hotting. I don't know, actually. Let's have a look at it. So
it's actually a parcel issue, if I remember correctly. There's some kind of issue with it can't monitor all the files. I read up about it once, but gave up.
Oh, it could be because it's, I don't know. So when I press save here,
It's
does it actually
supposed to watch it.
ELM? Yeah, it does watch it.
It
so
does do that.
I don't know.
But
yeah, it doesn't seem
it breaks every now and then.
Okay. Yeah, I don't know. So here, there's definitely a little cheat here because you can see that we're not using flags, right? So this init can be passed some flags, and you might go like, but what are these flags? Actually, I'm going, what are these flags? I think that these flags, can they just be anything? I think that they can just be anything, right? So I could say like, actually, I want this flags, and I want this to be an int. And how does this work? So flags is for something. What are
flags be properties? Like if you're making your own component, like pass in the properties to initialize.
Yeah,
that would make sense to me, at least. I ignored that in my example because I didn't know what the hell it was doing. But that would be my assumption.
I totally think you are right. It's almost like, so you know, if for example my app, as it runs, right, it could be passed something. Like I could give it stuff. Like I could say hello up here or something, right? You know what I mean? And that hello is like, is almost the starting condition of this application. Like the URL at the top is one of the starting conditions. I mean, it's here. It like comes. I don't have to go and ask for it. It's like it was there before my app even ran. And I think that's what flags is there to deal with. But it probably is. Oh, here we go. Interrupt flags are a way to pass values into ELM on initialization. Totally makes sense. Common uses are passing an API key, environment variables, user data. Can be handy if you generate dynamically. All good, yes. Okay. So when your app inits, okay. So when it inits from the JavaScript side there, I can pass flags in like that. So this is like, I suppose it's on the interrupt thing because this actually happens in the background. So I could say flags Miguel or something there. And then I wonder what type flags is. So if I said, actually, I want Yes, flags, but does it have to be called flags? Can I put string here? No, it has to be called flags. Okay. We call Elm make flags in Elm. To handle flags on the Elm side, you need to modify your init function a bit. Yes, init equals init. Init takes an int. That's what I did.
It's your main function, I think. I don't know if it's linked. You see that unit that parts to program?
Oh, yes. Good
So I
one.
don't know if there's a little bit of magic that looks at what that is.
This thing has to match that thing from a type perspective. So remember that program, when we put this unit here, when we put this jobby, that thingy there, we are saying flags is of that type, open close bracket.
Okay.
And so when it looks down here to look at your init function, it's going flags now gets populated with whatever the type is that you specified up at program level. And because I put this here, I'm being clear about it. If I don't put it there, then I could just go int. And then the compiler would go, oh, you didn't never put it here. So I know it's an int. You know what I mean? But because I'm specifying it, because I'm being cool, it's going, oh, there's a mismatch here. Now, actually, if we read this, the element call produces program of int of model my messages, but the type annotation says it should be program of unit of model my messages. So absolutely. So so if we wanted to say we were doing that and we wanted to pass some name, the name of the person in here, I would say, yes, my int, my flags is a string, and this would be the guy's name now. And what would I do with it? I don't know. But I would now, my program must also be specialized on type string. So it's a program which is initialized on a string, it uses this kind of model, and it uses these kinds of messages. You happy with that? So init technically could, so if we changed our model, our model at the moment is just an int, and this is great. Maybe let's make this cooler. I don't think we're going to get to
Chuck Norris category.
Yeah, so we have this plus minus gadget. What if we also want to put down, let's like make a new div underneath this thing, div. We're going to put the text of like something from the model. So it's going to be like the name, right? I'm just going to put here, it's going to be a compiler error. Some kind of name. We want to print the name that we got initialized with over there. This is, now we can just follow the compiler because it'll say what the hell is name here. And I go, okay, actually I want it to be like the model.name or something. It's going to say, but model is an int. And I can't go .name on an int. So I go, okay, so model's the problem. Oh yes, I don't want it to be an int. I actually want it to be something like a record. And let's make it look cool. The record has some kind of value in it, which is that int that we can increase and decrease. But we also want to attach some sort of string to it, which is that initial value that we got set to Miguel, right? So I can do that. So I could probably fix this one. I could say, oh yes, the int that we want to show here is the value int. Agree. So like our view looks good now. There's some compile errors there. This thing, let's start at the top. So we'll go, okay, so now in init, we need to give it a model, like it's the starting model, right? So we can go, okay. So I can give you that record. Let's make how would we indent this better? I'm flipping between languages. So I think a good indentation style is maybe this one. Let's go with it. So we'll say value equals 0. So we want the value to be 0, but we want the name to be equal to the name, right? The name that was passed up there. You agree? So the name inside the record. Wow, this indentation is not great, eh? Like that, maybe. Does that look better? I don't know. Probably not. We're going to go with it. So there's our init. So we fixed it. So the first version of init, our first model is going to have value set to 0 and name set to whatever we got given up there. Subscriptions are nothing still. Keep going down. Now it's like, okay, so when we handle increment, what do we want? We get the model in, which is value. Let's not call that value anymore. It's now called model. We're going to say, okay, so we want to take the model. So effectively what we want to do is we want to take the model and increment the value inside it, right? or return a new model based on value incremented inside it. And now this is like not incredibly easy in ELM. And it's almost like you've got to think of this in terms of like the spread operator in JavaScript, right? So in JavaScript, we would go like this. We would go ... or ... model or something. And then I go, so it's that, but with value set to model.value plus 1 or something like that, right? Does that sort of make sense? Does that pause in JavaScript? Comfortable with that? So that's how we would do it in JavaScript. In ELM, there's a similar syntax. And I think it's like brackety. So we go brackety model, and then you go like with a pipe or something, and you say with value equal to model.value plus 1, something like that. That's sort of the way of doing the spread operator in ELM. So it's like, yes, I want it to be the same as model, but where I've changed the field value to look like whatever the original model's value was plus 1. Demi, comfortable with that? I could just go and paste that in there, and that would make our thingy go away. But you might say, well, that's pretty horrible. And it's like, can't I go like new model equals that, and then return new model here? You know what I mean? Wouldn't that be nice? And it's like, yes, you can. You can use something called let. I can go let that in this. That makes sense? Kind of formatted like that, or like this, depending on how you like to read it. It generally looks like that. Anyone ungrumpy with this? And it's because, remember, we're just passing command.none. We're always giving command.none. It's the second. But remember, we're always returning a tuple. The first one being the first element of the tuple is the new changed model. The second element is this command thing, which we've not gotten to yet. Right? So we're always returning that tuple. Is everyone happy with that? Or does there need more explanation, that this funky thing going on here? Because this is quite involved. Or you're just super comfortable with that? Go back there. Everyone's just super comfortable. Amazing. So let's just keep doing it. I'm going to go for decrement. We're going to take the new model, but now we're minusing it. New model. And now it's like when we reset it, we can probably just go, we've got to do the same thing. Yeah, because the name could be set, right? The name is set. On reset, we're going to take the new model, and we're going to set the value to 0. Pass the new model there. Horrible. Eh? Okay, but look, no compile errors, maybe. So let's check what it looks like. Minus. That doesn't look right. There we go. Needed to refresh it. So we can still plus things, we can still minus things. And look, Miguel's name is there permanently. And if I move this anything away, if I look at our time traveler, it keeps popping up, this stupid Teams window. Go away. Go away. Go away, horrible Teams window. There's our time travel debugger. And if we look at it, we can see the first. So we can go through all the models, right? The first event we got, or the first like message was increment. And our model at the time was, is this a model at the time? Oh yeah, our model at the time was, yeah, this is the new model. So where is the old model actually? I thought actually it showed it to us here, but that's not the new model, that little funny 0.
Yeah,
we actually don't see the old model. We only ever see the new model. I suppose the old model, so like the first one.
Because the first one isn't a message.
Yeah, it's not a message, but you would think that in it is like, you would like to be able to see what that starting model looked like. Anyway, so you just see the adjustment of it, but you can see Miguel passed up there. Right? Semi-happy with that, or questions? We've got 4 minutes for questions. I think that's a good place to stop. So we can ask questions now. Anything funny? There's definitely some formatting nasty shit going on here. I wonder what is the best way to do this. Best way to format it.
Would
Probably is like
in
this.
would you not be able to use the let syntax there to make that cleaner in the init?
Oh yeah.
Yeah.
Yes, totally. Yeah, that's a good idea. So we say let model equals this shit. Something like that. And go in model like that. Yeah.
And
that's better, right?
a follow up to that is how is model scoped? That let model.
You're right. Yeah. So it's actually keeping in mind that every function is only a single expression. So even this case up here. So update is only a single expression. There cannot be more than one expression in any function, right? So update equals case. You know what I mean? And so case must return the thing that update is. It must be of the same type. So this case must literally return that thing. You know what I mean? Whatever update is that it needed. And so when you do let things here, you're actually doing absolutely zero. You're not even creating a new variable or anything. All you are doing is the compiler is going to grab this thing and it's going to paste it straight in there.
Would I be right to say then, because of the ordering, you could actually do the let at the top for the update specifically, do the let and in on the top level of the function, and then have the case inside of that for more of a so you don't have to repeat that in output all the time, because the only thing that's really changing in each of those cases is the new model portion. Like,
oh yeah. I hear you. Yes. So here you could say, well, this is redundant because we're always doing a command.none, right? Yeah, absolutely. So actually, it's a great example, Miguel. Let's take this update function and let's rewrite them in the madness that you're suggesting, and let's see what it looks like. And I'll show you exactly how you do it. And it's so obvious. It's like, so say we're going to make now an update 2 function, right? Update 2, and we're just going to refactor this one. So we're saying actually update 2 must return a model with a my message. So you could just say, well, it's model and like this empty command thing or something, right? I wonder, does ELM support where syntax, Matt? Do you remember? I don't think it does have where, does it? Where?
I don't think so.
No, it sucks. So we could just go let model equals something, and should go question mark or something, and empty command equals something in, right? So it's like, yeah, it's only going to be this model and command thing. And now we're kind of refactoring it. So we're always saying empty command is always command.none. We agree. We could have just put it down there if we liked to as well. And then we can move the case up to here. Does that make sense? So we can move this case statement. Let's just do it quickly. Like I'm just going to literally blast it right there. Don't have a mouse, which sucks. I'm going to indent it like that. And yeah, let's just do that. Oh yeah, it always has to be model. We do have to keep this crap. New model. Yeah. And then it would just be no command, but a new model. Does that make sense? Something like that.
so would we not remove the let and just return the bracketed section, the bracket model pipe value equals, and everything else gets removed? Because if I remember what you mentioned on expressions, it's like the last line to evaluate is what's returned.
Yes, of course. Yeah, of course. Okay. Yes, you
understand.
Okay. Yeah, like that. Yeah, absolutely. Exactly. And it's probably done quite a lot to make our code neater. Like that. Model Oh, I think I've just got indentation issues now. There we go. Let model equals shadowing model. Okay, new model.
Make it the M2 command just cmd.none.
Yeah, there we go. Perfect. Thanks, guys. I've got to run to another meeting.
Cool. Thanks.
Cheers, dudes.
Just.
Cheers, guys.
Thanks for the session, guys.
Yes, guys.
Cool.